Let's take a look at dividing rational expressions. Very similar to multiplying rational expressions because you are dealing with rational expressions that contain polynomials, and those polynomials need to be factored out. And also the rules of division become multiplication. So essentially, if you know how to multiply polynomials, this is very similar to that. You factor and then you follow the rules of division, and then it becomes a multiplication problem where you can just cancel the terms and get the answer. Very similar to what we just did. So let's take a look at the problem. It says, you notice that we're not multiplying, we're dividing. And you remember the rules of division is that we want to keep, we want to change, and we want to flip. Very casual terminology here, but what I'm doing is I'm keeping the first fraction the same. The division changes to multiplication, and then the last fraction to the right reciprocates. We're doing the reciprocal, so we're essentially flipping the fraction. You know, the denominator now becomes the numerator now becomes the denominator. So again, keep, change, flip. So we're going to keep the first fraction identical. Okay, we're not doing anything to it other than rewriting it. And then the division changes to multiplication. And then we're going to reciprocate the fraction, do the reciprocal. So, like I said, the denominator becomes the numerator, and then the numerator becomes the denominator. It essentially switches their location. I kind of like to say the denominator moves upstairs, and then the numerator moves downstairs. Pretty simple. And then now we factor every polynomial. The one to the upper left, we can take out a GCF of x. Again, take out the smallest exponent. When you have the same variable, when you have two terms with the same variable, you take out the least exponent, so it's going to be x. And then that is basically, well, x times what is x squared? Well, it has to be x. And then plus, and then x times what gives me x? Well, it has to be 1. So you can kind of play that game, what needs to be in the parentheses in order to get the polynomial back. We're going to do the same with the lower left polynomial, the denominator, okay? The most we can take out, again, numerically would be just 1, but exponentially we take out x squared, okay? Take out the lowest exponent. You don't need to put a 1 in front of the x squared, but you can if you want to. And then what's remaining? Well, if I take out an x squared, the 5 stays inside, right? And then the x cubed reduces to x, because I'm taking 2 of them out. And then we have minus 1, because we're taking out the x squared completely, so x squared times a minus 1 is the only way to get a minus x squared back. So try to distribute, try to work backwards to see if you can get the original polynomial back, and that will kind of help you think about what needs to be in the parentheses. Okay. The upper right-hand fraction, the numerator, okay, that's a difference of 2 perfect squares, because 25 is a perfect square, and so is x squared, and then 1 is a perfect square. And perfect squares are quantities that are multiplied itself. So 5x times 5x will give me 25x squared. And then, of course, 1 times 1 is also a perfect square, because you're taking the number 1 and you're multiplying itself, and that gives you 1. So make sure you don't forget that 1 is a perfect square. Again, the signs have to be 1 is positive, 1's negative. Doesn't matter the order. And then the denominator is going to have to be factored. So again, if you take out, let's go ahead and do this off to the side. I'm going to write it over here, okay? So 10x squared plus 12x plus 2. We can actually factor out a GCF. And when we do that, we're going to get 2. And then that reduces the trinomial to 5x squared plus 6x plus 1. Okay? So we want to make sure we factor a GCF when possible if you have a trinomial, because it'll make the problem much easier to factor. All right, so a GCF is a really good idea in this case. So take out the 2, and then now we're left with a trinomial that's a little bit simpler to factor. So if you want to use the AC method, okay, again, you take the A coefficient and you multiply it by the C coefficient, and you're going to get 5. And then all the factors of 5 are just 1 times 5. Okay, so not too much of a choice here. You notice that 1 times 5, 1 and 5 actually give me the 6 in the middle. Okay, so let's see if we can practice our AC method. Again, write down your first term, 5x squared. Write down your C term, which is going to be a 1. Leave some space, and then choose 1 and 5. And since x is my variable in the polynomial, I'm going to call that 1x and 5x. Okay, now the only way to get a plus 6 in the middle is both of these have to be a plus. So again, use that B coefficient to guide you on what the signs have to be. If you want a more methodical way of factoring a trinomial. We're going to do factor by grouping. That basically means we're going to split the 4 terms into 2 separate groups. We have the group to the left, 5x squared plus 1x, and then the group to the right, that should be a plus 1. I forgot to write the plus 1, the plus. Anyways, 5x plus 1 would be the group to the right. So let's take out the GCF on the left here. Well, basically x is common, so we're going to take out an x, and then you're left with 5x plus 1. And here, the only thing that we can take out is a plus 1. We have to factor something out, so in this case, the only thing that's common is that plus 1. And then again, we're just left with 5x plus 1. Okay? And then now notice that these are identical, so we can go ahead and choose one of the 5x plus 1s. And then this and this go in their own set of parentheses, which is x plus 1. So you're going to have your 2 factors. We're going to write them as x plus 1 here. And we're going to write our 5x plus 1 here. Okay, so yeah, the hard part is factoring. So once you managed all your factoring, now you can do the fun part, which I love, and that's canceling like terms. And a lot of things are going to cancel here. If you look at this, the x plus 1 cancels, the 5x plus 1 cancels, the 5x minus 1 cancels. Okay. Going back to here, you remember this 2 that we factored out of the original polynomial? We need to bring it down as well. Okay, so I need to put that here. So good thing I caught that. So yeah, if you go back to the polynomial, let me just recap. When we go back to the polynomial of 10x squared plus 12x plus 2, remember we originally factored out that GCF of 2? Don't forget to bring it down to include it with your 2 factors. That's really important. The 2 doesn't just disappear, it needs to be included. So when you write it here, make sure you write 2 times x plus 1 times 5x plus 1, and then cancel, which we've done already. Nothing else is going to cancel, so I basically have this left over, this term left over, and this term left over. So again, let's go ahead and write that. Okay, so we have x over, now 2 times x squared is just 2x squared. And we can cancel one more thing. I could have done it earlier, but that's okay. You can cancel one of the x's, and then that's going to reduce to, again, x goes into x1, so you need that 1 there, and then 2x in the denominator. And that's your final answer. So a little bit of a process, but essentially you have to be really fluent in factoring and knowing the different ways of factoring, when to factor, because depending on the polynomial that's given to you. And that's the answer, 1 over 2x.